Okay, I am recording us.
Did you upload it?
Gosh. I am going to record myself
I was like question 16, I'm like,
uploading something.
40 minutes? Am I going too fast? And I was like, oh no, I better slow down. So I was like questions like 16 and I was been there for 40 minutes. And then like it just crashed, so I had to go back and do it. I was like, alright. Some person went to the bathroom for like 30 minutes and that's how I stalled time.
That doesn't surprise me.
Is this guy still delivering stuff? Oh,
Okay, look now. I think he got swept up by the tornado. That's why his truck isn't there anymore.
no. There's nothing on this. There's no examples.
I know.
Wait. There's only 2 problems too. Wait.
Each problem takes so long that your homework is 2 problems and our examples is 1. They're also
Wait, it
kind of, I
actually takes
actually
that
find
long?
that they're fun. I really like them and I am serious about all that.
Oh,
They genuinely are so long that we only.
Oh god.
I think that you can learn how to do it with 2 problems as your homework. I could give you more than that if you prefer.
9F. That's good. It's be 9F. 9S.
I know that Nathan doesn't have enough to do.
Yeah, I could always use more.
Yeah, everybody but Nathan, you've got 2 problems. Nathan, if you want to add like 2 or 3 more, look for the hard ones though. If you could do that for me, I'd appreciate that.
And then you can start on other stuff for the rest of the weeks we have left. Right.
Yeah, might as well just finish the school year, you know?
Take the AP test right now.
All right, here we go. I just put a whole bunch of this stuff right on there. Now the symbol N means it's still like your sample size, but this time it's the number of pairs of data. So these are dependent samples, which means it's a 1-to-1. This point is connected to that one. D is the difference between each entry in a pair. So you have many differences. So like, for example, you would say something like, this weight loss drug, this person lost 6 pounds, so their difference is -6. This person's -10, this person's -20, this person's plus 10. They gained 10 pounds on this drug, you know, or whatever. Do you understand what differences are? The mu sub D is the hypothesized mean of the differences of the paired data. This is your control group, which means that the mu sub D should equal 0. The D bar is the mean of the differences. And this S sub D is the standard deviation of the differences. Okay. All of the steps are here, but I am going to go straight to the example that we're going to do together. All right. A shoe manufacturer claims that athletes can increase their vertical jump heights using the manufacturer's training shoes. The vertical jump heights of 8 randomly selected athletes are measured after the athletes have used the shoe for 8 months, and their vertical jump heights are measured again. The vertical jump heights in inches for each athlete are shown in the table at alpha equals 0.1. Is there enough evidence to support the manufacturer's claim? We assume that they're normally distributed. Okay. So we're going to start by, does everybody understand why these are dependent samples? Why these are paired? Right. Like this athlete right here could jump 27 inches vertical before the shoes and 30 inches vertical after the shoes. There would be no reason to compare this person's height to that person's after height, right? You use the same person before and after. That's why these are all pairs. Okay, so the first thing we're going to need to figure out is all of the differences. Okay. So what do we want from this? It looks like this one. Now, you can do this two different ways. I would prefer to call this a positive 2 difference because to me it looks like they gained 2 inches after wearing the shoes. You guys understanding that? But some people would say, I'm going to take their vertical jump height 1 and subtract their vertical jump height 2, and that would make this negative. And then I'm hoping for a negative number because I want their first one minus their second one. I want all their second ones to be bigger, so I want the average to be negative. I'm just switching it in my head. So I'm doing V2 minus V1. It's just kind of like a slope scenario where you can decide which one you want to subtract first as long as you know what you're talking about. So the difference could be like if I was expecting it to be negative, I could end up with a left-tailed test compared to a right-tailed test or whatever, but either way would still work. This one, it looks like they have a positive difference of 3. This one's 0. This one is 1. What would this one be? Negative 2. This one's positive 2. This one's positive 5, and this one's positive 3. All right, now for H sub O and H sub A for this one, you're writing mu sub D for this. Mu sub D, and we're always comparing it to 0. So what do we want to have happen in this? What do they want? They want the general difference to be positive or negative? Positive. They want it to be, wait, hold on. Their claim is that they can increase their jump height. So they want this. This is their claim. They want the difference to be positive. Opposite of that would be less than or equal to. Do you realize that if you had done instead V1 minus V2, you'd be hoping for them all to be negative? And it'd be the opposite kind of test? Okay, it's a normal distribution. Let's draw a bell curve. This is a right-tailed test. The book likes to do this. I'm going to show you guys. Everybody look up. The book always chooses to do take the before minus the after, so they would want a negative difference in these jump heights compared to a positive difference, like we have. But anyway, did I mess up something? They have 2 that are 0. No, just 1 that's 0. And that one's positive. Oh yeah, that's right. Okay. So the next thing we need is we need a edge of a rejection region. If you go back to the front, you can see that we have to identify the degrees of freedom. This is going to be a t-test. And our t-test